Ah! I am muted. Okay. Thank you, Dredsky, for pointing that out. I am now unmuted. Welcome back. How's it going? Welcome to the stream. I'm going to start the whole intro over again. This is the project so far we're working on. It's called Lambda Trek. It's, like a lot of our projects on this stream, built in Haskell. We're using the brick library to build this kind of nice terminal UI. And Lambda Trek is a game based off of, like, Super Trek and its various clones. You're a captain of a starship, and you're fending off an invading alien force in your quadrant of space, and you have to defeat all the invading ships before time runs out. So last week we got the command input widget implemented, and so you can input a couple of commands that we have that support so far. There's a lot more into the game, but we just have the 2 for now. And this week I think we're going to get working on implementing a widget to represent a sector of space so that we can render the ship, and we can use this handy dandy move command to move the ship around the sector. And that's how we're going to do. That's how I like to make games and stuff, and a lot of programs I like to start in small little steps, make something as usable as quickly as possible, and just iterate from there a little bit at a time, little tiny baby steps. So let's get to it. Yeah. This is our code, and if this is your first time tuning in, of course, like Dredsky, you can stop at any point in time, ask any questions you like, and I am happy to oblige, chat. Happy to oblige. Okay. So let's think about a sector. A sector is going to be like a grid. It's going to be a tile-based grid, and the way it works in the other games, and the way I think it's going to work in this game, we're going to have one thing per tile. We're going to make it super, super simple. And the different things we can have in the tiles are like the starship itself, where the player's location is, stars, empty space. We gotta have the enemy ships, of course. And I'm thinking maybe we'll get to adding planets. That would be nice. Maybe we can see what we can do with those. So let's just have like a grid. I don't know how many we're gonna have. Like maybe, I don't know why it's this. Oh, I got the new version of this thing. I've got this tool I have here. I'll draw. There we go. My fancy dancy mancy schmancy grid here. Okay. So we're gonna have one thing per tile. We'll start off with just the ship and empty space. I'll just put like a little dot for empty space. And then eventually we'll add stars. We'll just make those like stars. And enemy ships. I'll make like arrows or something like that. And yeah. And so then moving is another thing maybe we'll get to, hopefully on the stream tonight, where you input that move command. You've got to give it, these sectors, grids will be numbered like 0, 1, 2, 3, and so on. And you input one of those numbers, and as long as it's empty space, you can move there, basically. And the ship will just go pop over to there. And if you try to move somewhere where you can't, there's something already there, like a star and an enemy ship, or what have you, then we'll have to have some way of displaying errors or something like that to let the player know that that's not a legal move. Hopefully pretty simple and straightforward. Okay. So first thing, we need a way to represent a sector. I'm going to hop back over to my editor here. We're going to start a new module, simulation, and we'll put our sector.hs module here. Simulink, Lambda Trek, simulation. Oh, no, that's not what I wanted to do at all. Sorry, I wasn't paying attention to the command I inputted there. Let's go to a simulation. Let's get rid of that symlink. I wanted a file here, sector.hs. Okay. Lambda track. So just make sure, I know some people might have trouble seeing the font size. Hopefully it's good for you. Lambda track, simulation, and this is the sector module. Okay. So how are we going to represent a sector? Well, it's going to be like a 2D grid. And those are because the command's going to give it into like an XY kind of coordinate into the grid. We could probably just use an array. All right, so we're going to need some way of representing the different tiles in the game. And those will be the values of the array. And then the coordinates, we can do some little index programming to figure out where in the array it is. So the size of our sectors, let's just make them, I don't know, something arbitrary. And we can make them like 15 by 15, say. So I'm going to port data.array. That's the built-in array module. And let's, I don't know if we should put tiles in a separate module. I'm just going to put them here for now. And we'll have the player, ship, and empty space. We'll derive a couple of base classes for this. Bounded, EQ, enum, EQ, and show. So we haven't really used these ones a whole lot on the stream. So if you haven't seen these before, bounded and enum, just turn these into enumerations, like in how other languages tend to represent enumerations as like integers and stuff, like indexed into this thing. So we load this up. We just go info on enum. That's the type class. You get the successor and the predicate elements. So that means like the next element in the enumeration, the previous element in the enumeration. You can go to enum. So from an integer to an enum value of the thing from enum and so on and so forth. And so if we go say to enum 0, and it needs to know what we mean, so we have to enable type applications here to use it in GHCI -x type applications. I can go to enum tile 0. Oh, it's not. Sorry, I gotta load that data, that module. Oh, we have to add array? I thought that was in base. Probably, okay. Let's just add it to our package quickly so I can load this. Array. Oh, don't worry about it. Okay. Process restart. There we go. Okay. So be able to enum and I forgot I have to re-enable type application because I restarted the GHCI process. So on and so forth. Okay, there we go. To enum tile 0. Right. So we can go when we get empty space. So when we write out our array of these tiles, we can convert them to these values. So from enum could get us to an integer value, like from enum player ship. If I meant player ship like that, then we get to 0. So far, so good. All right. Let's do a new type wrapper for our array. Call it sector. And the sector will be an array with an integer index and an integer value. We can derive a couple of classes for this. Hey, Damien Frell, welcome back. Nice to see you again. Hope you're doing well. Okay, so our sector here is just in a new type wrapper, so we can differentiate it from just regular arrays. And now we got a nice type level representation of a sector, but underneath the hood, because it's a new type, it'll just be treated and desugared as just an array, a regular old array. Which is nice. And yeah. So let's create an empty sector. So an empty sector will just be our sector, say 15 by 15, and it'll be full of empty space. We could even make this take the size parameters of our space if we wanted to be able to create empty sectors of different sizes and try different ones. I'll try that. Then we can make, you know, those parameters a constant maybe in the main when we're constructing the game and building it up. I mean, those will be fixed anyway, so I'm not really sure it's useful to do that. Let's just make them a fixed size. Okay, so sector, then we need to use the constructor here to create a sector, and then we need to construct our array. Array has a bunch of different ways of constructing them. The one I think we will probably use is list array. That'll be the easiest. And so a list array. Our list array is going to take our, I think, bounds argument. Yeah, the tuple I believe is the size of the array. Sure, but why is it a tuple? I think maybe because we can actually get, yeah, two-dimensional arrays. Anyways, I think that's the right proper value for it. And then a list, well, we're just going to repeat empty space constantly. So we don't actually need to like construct the right size list. And this isn't just going to be plain old empty space, it's going to be from none. Okay, so like internally we will save the tiles as ints, but using and getting something out of the sector for rendering, we're going to want to display, we're actually going to want the tile value. So we'll need like a get function to get something out of our sector. Right. So we have a couple of different ways to index into our array. We have the kind of bang function, where it's going to be I to get some value out. And I think this is probably unsafe. As you can imagine, if I is outside the bounds of our array, we would get an error. Right, but there's no error type here on the right-hand side of this indexing function, right? It's just E, which is this E over here in the definition of the array, which is the value type. So we have in range, range size, unsafe range size, bounds, LMs, indices, mix map. So we'll have to, we can check if it's in the range first before we go to access it. So if you want to give int, your x and your y, we will give you back maybe a tile. Okay. So let us try to construct our index using some of those array functions that we have there. Let's see, it is word range index. Index, yeah. I guess index is probably... Or there's also bounds. Bounds will get us the bounds of the array. An I and an I. And then we could test if our x and y are within those bounds. I think that'll work. Yeah. Because the other one we can do... I'm not sure if index... how index will work, actually. Let's check our documentation. Haskell data.array. So list array, key array, indices, elements, soaps. Okay, bounds. Let's do bounds. We'll get bounds. So bound of x, bound of y. Oh, we need the array, of course, or the sector. So we'll get the sector array, sector data, get sector of sector, and bound x, bound y will be bounds of sector data, and then we can check if we're going to have a guard first. The first x and y have to be at least 0. And both of these things have to be true. Otherwise... Otherwise, nothing. And now in this hole here, we know that x and y must be at least greater than at least 0, and they have to be less than bx and by. So and both of these things have to be true. And else something. Okay, well, in the then case, we know what we can put in there. That means we're within bounds, so we can index in a sector safely. So that takes our array, the index we want, and gives us a value. So sector data. And then we have to calculate our index. This could just be a straight up that. And, oh, that has to be a just. Okay, and then we're going to need to compose that just with 2 enum. Okay, now we just need the whole of int. And this is, we're going to use, oh, I forgot the actual name. It's like row major ordering. So the idea would be that we can take the X index we want plus the row width. Right? Yeah. It's X plus the row width and the times the number of No. We want to get the row into the index. Let me draw it out. It's easy to explain that way. Here's our grid. Happy little grid. We're going to, in order to get the row we want to get to, we got to multiply the size of our row by y, the index into the vertical index, basically, quote unquote, if we're going from like a 0, 0 in the top left kind of coordinate system here. All right, that'll give us the row offset into the array, and then we want to add the index to get the column offset into the array. So leave that hole there. This will be our formula. Y times, we said our height's going to be fixed at 15, and we add X to that to get the column. Otherwise, nothing. Now this is quick and dirty, kind of just filled in code. We could probably make it a little nicer. Let's just try a couple of examples. Well, it's all going to be empty sectors at the moment, so let's just do like a quick little sanity check of the empty sector. Okay, so we're quite out of range here. And this is what I mean, that this function here isn't safe. Exception here is like an IO channel exception. It's like just throwing to the wind, stop the world kind of things, which is not exactly what we were hoping for here. So that's out of range, because I kind of expected when we constructed this array that we were going to get thing here. So I think maybe my idea of how this works is a little off. Okay, a pair of bounds, each of the index type of the array. These bounds are the lowest and highest indices in the array in that order. Okay, okay. For example, a 1 origin vector length 10 has bounds 1 to 10, and a 1 origin 10 by 10 matrix. Okay, okay, that makes more sense. Now that makes more sense. So this isn't 15 by 15. What we want is actually, if we want a 15 by 15 grid, we want 15 times 15 elements in our array. And we want to go from 0 to 1 minus that. Or 15 times 15 minus 1. So I don't think it's inclusive. Let's reload that. Okay, that's not quite right either. We should get 15 by 15 at least without throwing in exceptions. If we go 16, we should get nothing. Actually, we shouldn't throw any exceptions anymore at all. Okay. So we get empty space there. But probably nothing else anywhere else. Just at 0, 0. I'm gonna make that 15 times 15. Width times height. No. Okay. Okay, well, let's make this example a test and start there. Okay. So for testing, we're going to need a library. We're going to need hspec. And we'll do it like this, hspec, describe Lambda trick, that's simulation, sector, and we'll describe the get function. It should get the tile 0, 0. Alright, so if we create should be just empty space. Actually change this to 0, 0. And 15, 15. pretty decent example. And we'll just change that there. And something completely outside. Seems reasonable. Okay, and then we'll set up our tests to run in the background while we work. Tests will be fast with our file watcher on. What's this here? Oh, file watch. There we go. Not file watcher, file watch. I was typing what I was saying, which is super fun. Okay, so that means we can start using just the tests to drive this. Okay. So our formula here so 0, 0 works because if we do y times 15, that's 0 plus 0. Okay. And we expect the first row, if it's 15 elements long, to be from 0 to 14. So 1, 1. If y is 1, that's 15, plus 1 is 16. Okay, so we want this not to be 15. Want to be width minus 1. Oh, yep. And in order for our test suite to compile, of course, we have to import our library thing that we're testing. Lambda track, simulation. Dot sector. Okay, 0, 0, test pass, but the other one, 15, 15 fails, and out of bounds passes. So we kind of expected this one to pass, because like everything's returning nothing right now. This one, we need to make work. Okay. Yeah, this should be... Let's see. Here's our array, it's laid out continuously, like that. Our grid version, our representation of how we want it to look is like this, and we want to index from 0 to 0 up to, in this case, 1, 2, 3, 4, and 2, 3. So our width is here. In fact, I'll make that a different color. So this is the width. This is the height. H. And then our index I. And J could be the vertical one. So in terms of our actual array, 0, 0 is just going to be 0. 1, 2, 3, so on up until 4 times 3, which should be like 12. Alright, so this one here, this would be 0, 1, 2, 3, 4. This one would be 5, 6, 7, 8, 9, and so forth. So at J1, I1, we want to get 5. So in order to get J, we'd need, if J is 1, we'd need width. J times width would be 4. 1, 2, 3, 1, 2, 3, 4, 5. So that'd give us 4. That's no good. There's 5 elements there. So the width is actually 5, sorry, not 4. It's 5. And height here is 4. Yeah. So J1 times width 5 would be 5. And X1 would be 5 plus 1 would be 6. So that should go to the right place in the array. Alright. So our width is 15. Y1 should be 15. And X1 should make it 16. Okay, but we're still getting a failure here. Okay, so I'm still not getting what I want here. Is it because because repeat is not fully realized in the list? Let's check that. I'm curious if maybe that's it? What if we constructed using list comprehension, just to test that theory? So we'll go to enum, from enum, empty space, and we're going to do it from 0 up to width times height, 15 times 15. Let's write that in parentheses. Oh, it's just a type defaults warning. Okay, tests say no, that's not the problem. Is it our array bounds? Let's Show the empty sector. Okay, 225. $225, that's our maximum index. Zero is our minimum index. That seems good. What am I missing here? What is 15? Ah. If I try to make y 15, and then we add x, which we said was also 15, we get 240. That's out of bounds. That's why that doesn't work. Okay, that's good to know. Okay. So. What do we gotta do here? We gotta do... We did y15 and width minus 1 is 14. That's only... So we wanted 0 up to 15. Our index is to be... Our indexing is 0 based, and I'm thinking about it in 1 based, as I think the issue. We should be able to go 14. That's 224. Which still leaves off 255, actually. And if we do 15 times 15 minus 1, which would be 14, plus 15, that's 225. Okay, so in order to make this to pass, at least, that has to be width minus 1. And it won't. So let's try to get 1-1. We have to say no, still won't. What am I doing here? What's going on? That should be fine. Even with an incorrect formula such as this. Oh, yes. Bound. This is not the problem. This is the problem. I'm checking for bounds. Bounds is not right because remember, my idea of this being 15 by 15 is wrong. So BXBY is not correct anymore. This is the problem. This is the problem. Okay, so our sector, in order for us to check that the index that is given to us, X and Y here, are within an actual sector, we need to have more information in our sector about the width and height. That's the problem. My goodness, that took me a long time to figure out. Woo! Okay. So let's change this up. This will be sector data, sector width, and sector height. Okay, so the empty sector. I'm gonna do it like this. Keep that, something like that. Sector data. We'll get rid of the... We'll just go back to repeat because that was nicer. From enum empty space. Sector width 15. We could do it this way, or actually, since I'm gonna fix these anyway, yeah, we don't really need that actually. Like, look at that. Fine. Forget I did all of that. We're just gonna go with an array in the new type, like we had, and we can just put a guard on it. That's what we're gonna do. X is greater than or equal to 0, and X is less than or equal to 15, and Y is greater than or equal to 0, and Y is less than or equal to 15. This is the way. This is nice. Here we go. Sector. Well, we'll do it with a function this time. No, deep. 2 enum. Yeah, we gotta get sector index should be Y times our width, which are 15 minus 1 plus our X. Otherwise, nothing. Yes, get rid of that. Repeat from enum empty space. Oh. What did I do? Yeah. 16. It's probably just, yeah, probably just like parenthesize some sort of operator mismatch, overloading, whatever thing, probably. No, 16. How am I getting 16 now? What's going on here? Bring this over to the left a little bit. Okay, so if we get into this guard, it has to be that x is at least 0 and y and less than or equal to 15, and y has to be at least 0 and less than or equal to 15. Right? And empty space should be 1. Empty sector. All those values should be 1. Yes. Let me just bind this out a little bit here. Oh, that's totally not right. What the heck? Two enum. Two enum. Come on, two enum. Yeah. I should be able to infer that that's the right tile we're looking for. How are we getting 16 from indexing the sector data? Oh, there we go. It was, yeah, parentheses somewhere in the wrong place. Okay. There we go. Okay, that is our get function. That was a little bit more work than I had anticipated it being, because usually it's not. But there you go. Great. So now that we know we can get out of our map an appropriate value, it would be nicer to have a get function that like didn't return a maybe, but this is good enough, I think. Okay, so we can get a tile out, and then we want to be able to map, when we want to render a sector, we want to be able to render the tiles to a character to display in our TUI. So we'll have like a render function for our tile, do some char. We can even make it a text. That way I can make the player ship a little bit special looking and empty space to make our dot. Of course, in order to use that syntax, we have to enable the language extension lambda case. That's the one. And in order to use text, we need the package text. Which, oh yeah, we just have to import it. Okay. Just import the type for now. We're not using anything from that package, just the type. And we need overloaded strings. Okay, that should be good there. Sweet. So we get from that, we render, we adjust, done, super. As one would expect. I'm going to move the tiles over to their own module, a sibling module. And track simulation. I don't know if it should be in the simulation though. It's more of a rendering concern, but it's also data that we use in the sector as well, so maybe it should be there. Move that import over. And what else? These extensions. Yeah, and then we can import that in. And then we gotta fix the test module. Super duper. Okay. So now I can have a render function here for our sector. Let's see, how are we going to do this? Okay, let's get the sector data out. And then need a hole. Okay. So first thing we could do with this is we can map the sector data to the tiles. To enum. And in order to do that, we need an array function to convert the sector data to a list. Unless we have a map directly in array. Index map, LM's indices. Accumulate. LM's, yeah. Okay, and to get rid of that, we need data.text. Okay, and 2enum's confused about what we mean here, so let's just give it a type hint that we want this to be a tile. Okay, and now we have a list of tiles to text. So this is going to be our full 225 list of tiles. And we want to render it to a fixed width. And I'm thinking each tile for our widget's going to render... Well, we have the ship rendered as 3 characters. And in order to make it look a little nice, we might want to have like a little padding around each of those things. So we'll make like each cell of our thing... We could make it... If we did it on each side, that would be 5 characters wide. And maybe 3 characters tall. Might be the way to go. Or we could do what we originally wanted to do with... Or we could just make them cars and make them smaller so that it fits in nicely. Because imagine 5 characters wide times 15 is quite large for our widget. So let's go over to tile. Let's render it as 1 character wide each. That way we can make each one 3 by 3. So like 9 characters in the terminal per square. But it still might be too much. We might just need 1. Let's try it 1 per. Okay, so this function needs to take this list and break it up into these chunks, intercalate the rows with new lines, and then to do it all together. So first thing we do is convert all the tiles to their rendered forms. Render. We're going to need to qualify this. We probably don't need that anymore because render will force that. And we'll import lambda track.simulation file. Just a type there. Oh, and its constructors. There we go. You think this is still ambiguous to you? Why is this? Okay, we still need that type application. Okay, fine. Was it, or was it the fly? That was the problem. Okay, it was just the applications. Okay. So yeah, now we have a list of text. These are like characters. All right, so every 14-ish, we need to intercalate with a new line. So we need to break this up into chunks. Data.text. Our list might have something like this too. Or we might have to write it ourselves. I might have to. Okay. Okay, yeah. Looks like we might have to. Like, there's a like chunk sort of thing. Okay. It's no problem. It's no problem. We'll create Lambda track list .hs. Create our little list helper module. Yeah. Lambda track dot utils dot list where chunks will give an integer chunk size, some list of A, and we'll return a list of A's of that chunk size, and the last chunk may or may not be the size you want. Okay, so this is going to be chunk size. We'll take what do we do? Something with, we need import data.list. I think we do tail. Do. Yeah, tails gives us a list of all the subsequent segments, longest first. So we had tails 1, 2, 3, 4, 5, 6. 7, 8. By import data.list. Yeah, 1, 2, 3, 4, 5, 6, 7. 2, 3, 4, 5, 6, 7. 3, 4, 5, 6, 7. 4, 5, 6, 7. 5, 6, 7. 6, 7. 7. Okay. You know what? Let's just look it up because I Google chunks. Somebody's written it before. Data list.split has it, of course. It has the concatenation of some recursion on it. Well, that's an interesting way of doing it. Okay. Data.list.split. Let's just import it. We don't need to have our own module. It's fine. Left pad. What's the worst that could happen? What's the name of the package? Split. Then we can import data.list.split. Chunks of 15. And then from here we need to import data.text. Text.intercalate. What's the new line? We gotta do. What do we got? That's not what I was expecting. What do we have in this folder? We have list of text. Okay. So we can join together each of those. With text.concat. Title will give us our row, and then text.intercalate. Which should give us our final text. Oh, I need overloaded strings there. That's that error. Language. Overloaded strings. Yes, there we go. Let's just line this up a little bit. Yeah, restart the GHCI process. Let's just check it out in GHCI quickly. Oh, sorry, brain fart. The qualified is in post positive. That's not the default. But that's the way I write Haskell at works, so it's just kind of wired into my brain. I have to do the same thing when I'm like working on open source libraries and stuff too. Switch it back over. Okay, compilation still failing because we still have a hole. Still a hole. Ah, you still have utils.list for some reason. Yeah, I forgot to remove it. For real, utils. Bye-bye. Cool. So let's try rendering the empty sector. Okay, that shows it out. That's good. For data.text.io, I think. Put text. Render empty sector. Oh, I forgot it. Data.text.io. Do-do-do-do. Let's stir. There we go. Let's see, actually. We got one extra /n that we kind of expected to be on the end. The length of these is 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 15. Yeah, that's right. Okay, we got 15 and then 1. That's not quite what I was expecting there. This might be our width problem thing again. No, now we got 2 on the end. That's not quite right either. How many rows we've got? 2. We've got 95 to 310. So that's 15, 16 rows. And that's not right. Something is not lining up with my math here. Chunks of 15. Okay, let's see, what are we doing on time here? Still good. Okay. Let's see, chunks of... Maybe it was not a good idea. I'm not sure. Data.list.split. Chunks of 3. Let's create a 3x3 list as a flat list, which should be 3 times 3, 9 elements. Right? X is going to be from 0 to 0, 1, 2, 3, 4, 5, 6, 7, 8, and 9 itself. Yeah, so that should be 0, 8. And then we would get the rows we want. If it's a perfect square, we should be 1 minus. Alright, 13 times 15 minus 1. But that breaks our test suite. Two 25s outside of our range. That should bring it back in. No? Oh, because we would need to be 14, 14. Would be our maximum index, right? So if we do a 3x3 array, that means we have 9 elements. Yeah, so if we did a 5x5 array, we have 25 elements. If we did a 3x5 array, that would be 15. But in the 3x3 case, yeah, 2, 2 would be our maximum index. If we're going 0 indexed. I think that's what's throwing me off tonight for some reason. I don't know why I'm not on it with this. This is correct. It's this which we have to change. And our test suite. Okay. So now let's try our still not rendering in chunks of 15. Still getting one off. Oh. Wait a second. Chunks of 15 should be right. Maybe this should be this one. There. There we go. Okay. Finally. Sorted it out. Should be 1, minus 1. These are going to be 0-based indexed. And everything. Okay. Now that we got all of that sorted out, we can render a sector. We can fool around with making it prettier, but let's get a widget going, so we can render this to a widget on our screen, or just maybe we can just render it out straight as pure text. Don't have to bother too much with widgeting. So we go to Lambda Trek, render UI. We need the right UI. Okay, so in our sim display widget, we just display the current command. We're going to need to add something to the state to say that we want to render the current sector. So this is our game state, and that's the current command. Our sector. We're gonna have like different game modes for this because there's different screens that we're gonna be working with here. We're going to be having the sector screen, which is where the user's going to be interacting with the sector. They're going to be moving around using their like low power engines, whatever we want to call them, impulse engines in the Star Trek universe, but something like that. And they're going to be battling the alien ships, the invading ships, and they're going to be, interacting maybe with space stations and planets and whatnot. Yeah, and then we have another game mode where it's going to be like the quadrant mode, where the display is going to display all the different sectors in the quadrant, and we're going to be interacting more with like long-range sensors and things like that. So kind of different game modes. And so we're going to like want to change what's displayed in the left panel based on which mode we're in. I think for now, just to get something going, I'm going to represent game state sector here as just a sector. And we're just going to mess around with this. And then when we want to start adding the different game modes, we'll refactor towards that. So we no longer can implement ORD for our game state because sector doesn't have an ORD instance. I think we should be able to add one. Because array has one. Yeah, what's the problem here? Yes, initial state, game state couldn't have it. So this is fine now. So Lambda Trek, when we initialize it now, we need to have empty sector. Import Lambda Trek simulation. Sector. That should compile. Okay, good. Let's get the builder working and going for this too, instead of the test suite. So that's fine for now. And so we're going to sim display, instead of displaying the current command there, we'll center the render of the game state sector. Don't have that function, so let's just import that. Import Lambda Trek simulation sector. Qualified as sector. And we'll change that to sector.render. Oh, it wants yeah, it should be a sector. Oh, I gotta use form state of F to get it. Okay. Let's pull that out. So, sector. That should do it. Okay, so our rendering library wants a string. We can just convert that string with data.text. That's no problem. Import data.text qualified. Data.text. It's text, and this will be text dot unpack, I believe. Cool. So let's check out our game. There's our sector. That's cool. I mean, we could make it a little bit bigger if we wanted to. That's not too bad though, for now. Okay, so we wanted to make the ship move around. So let's just take a pause here and check in some stuff. No, looks all pretty good. Stage all those in. Add sector. This adds a basic sector module to the simulation and renders it simply to the left panel. Okay, let's add the ship state. We could... How to represent that? Let's do it like... game state... Ship. And we'll add a new module to our simulation. Lambda track.simulation.ship. Okay, we're just gonna have a position for it because that'll be the simplest thing we could possibly do to make this go. Ship X and ship Y. And we're gonna need an ordinate instance. And we'll need to import it. Lambda track simulation.ship. Okay, and then in our ship module, we'll need a like init ship. And we'll give it int and return ship. Technically, it's going to be a smart constructor, but yeah. Because we don't want any old int, remember? We want an int that's like within an actual sector. So actually this X is... It's interesting. We do have X and Y's for quadrants, but they are types, not int. I'll take a look at that another time. Let's just make this work as quickly as we can. So let's just do ship XY. It's kind of redundant. In fact, we don't even need init ship right now. That is just so redundant. Let's go. It was the Lambda track module where you init the game state. We can do ship. Let's just put it at 2, 2. Okie doke. So that's our ship state. Let's render it. So how are we going to render this now? Let's go back to our sector. That defines the render action here for the sector. Sector is no longer enough. Unless we want to mutate the array with the tile when we change the ship's position. So what we would in order to do this now with what we have so far, we would have to pass in the state. Right, the state of the sector. So I think maybe representing... This is a good way to represent the tiles that we want to render, but the state of a sector is something different from what's rendered. Right? This is like the sector tiles. Right? And the sector state is like all the objects within that sector, which might include the ship. And then we could derive the tiles from the current state of the sector. We get the player's ship location. We would have to get all the planets in that sector and the enemy ships in that sector, their positions. We could build up the array from that. Or the sector tiles. Yeah. So let's ship extra bars, that's fine. That's fine. Add that and these. So we're gonna refactor this a little bit to handle this and separate out the concept of tile from the concept of the sector state. And fix that. So we'll just commit the ship stuff anyways. On ship. Okay, and then let's go back to the sector module. This is really sector tiles. This is get tile. Okay, so we're gonna fix all these type errors. And we have to fix the rendering that we have so far in the UI. Oh, and in the game state. And empty sector to empty sector tiles. I think that we're getting close to being compiling again. Okay, we are. Okay, so a sector now needs a bit more data. It needs to know from the game state the player's current position, and then everything else inside the sector. Okay. It's almost like something we derive from the game state, partially. Let's see. Sector like this. Right, so a sector. We'll have... Well, right now, we don't... I don't want to define everything right yet for a sector at the moment, but they're going to have stars. Alright, some collection of stars. Maybe they're positions. Sector enemy ships. A list of enemies. What's an enemy? Doesn't matter. EQ or show. Something like this. And now in order to render a sector, we need a function to derive the sector tiles that we want to render. We could like call it get or sector tiles. So in order to get sector tiles, we're going to have to give it a ship, sector, and then we give us a sector tiles. Okay. Now we can import ship. And we're going to need to be able to get the ship's X and Y axes out of it. And we'll import this qualified as ship. Okay. What's our other type error here? Oh, we need more instances for enemy. Okay. And now we got our hole here for sector tiles. Okay. So in order to derive a sector now, we need to construct an array for sector tiles. So we need the sector tiles constructor. We need array. We need from array list array. This is going to be 0, 15, 10, as our formula above is. Minus 1. Only this time, we're actually going to construct an array because we need to overlay data from about the ship, data from the sector, in order to and put those in the right position in our input list. And I think in order to do that, data.array might have a different constructor for us, where we can construct them with the indices we want things at. Or transformations on array indices. So we can xmap or cum. So a cum-f takes an array and an association list. That's this cat here. And accumulates pairs from the list into the array with the accumulating function f. That's this cat here. So an element, some input from the associated array, and a new element. Okay, so the accumulating function, yeah, does accumulate the values, but it's at those indices. Or we have the array function. Well, we're going to be defining, like, the exceptions to this. So we could set just in the index array. So, like, get tile, we could have a set tile. So let's leave this undefined for a second. Set tile, int tile, sector tiles, returning the new sector tiles. And so we will go call sector tiles here, and similarly to the get function, we'll check our bounds first. We'll put something there, otherwise this will have to be maybe, because again, int and int could be out of bounds.
I've been living in your shadow for 99999, keeping tabs on every machination.
nothing.
production line. So don't call me a moron, I'm super astute. There is no conundrum.
We could probably actually get rid of the maybe if we make the X and Y's mod over the width and height. And that way, if you input something like -1, it'll just wrap around like a torus. That might make it a little bit easier to work with. Let's just go with this for now. So in this case, we know that X and Y are in bounds, so we could just set the sector.
I have studied Machiavelli, Aristotle, Gabe, and Plato, yet you still
We can get the sector data and construct a new one.
to that of a potato. This place would fall apart without my ever watchful eye. They might tell you I'm a half-wit, it's a great big bloody lie.
Just
So don't call me a moron, I'm
or
super
here.
astute. There is no
We'll just use just. It's fine.
confused. No, don't call me
Just sector and
use the infinite space from
we're going to use the array update function.
I use the infinite space from here to the moon. My IQ's the infinite space from here to the moon. My IQ's the infinite space from here to the moon.
So we'll just get sector tiles. We have sector data
I know
and modified with an association list.
every cave, and since you're dead, I've quite appreciated.
That'll be X and Y, or
Maybe someday I might get to
the first value
for a change.
will be our Y
Much I do for science here, so much I
times 15 plus X, and the value will be the input tile.
IQ's the infinite space from here to the moon. My IQ's the infinite
Okay, and yes, we have to change that to from
IQ's the infinite space from here to the moon. My IQ's the infinite space from here to the moon. My
What's the
IQ's
problem
the
here?
infinite space from here to the moon.
Oh, we have a name binding on sector tiles here. Yeah, so let's rename this to generate sector tiles or project sector tiles. Render sector tile. Build sector tiles, maybe. Okay, so then we should be able to build sector tile or set tile. Let t's or sector t's st. So we'll set tile 1 1 to ship. Player ship, I think it was actually. We have to import that. Lambda track. Simulation.tile. So let st equal build sector set tile 1 1 2 of to player ship. And the sector tiles will be empty sector tiles. Okay, so that's ST now, and so we should be able to... Or data.text.io. Okay, output stir. Useful. I want Lambda track. And there's our S there, yeah. In the second row and the second column, so 1, 1. That should be right. We can implement the safe one version in terms of this. Okay, cool. And now for build sector tiles, we can use our unsafe set tile just to make it a little easier. To write, we start with empty sector tiles. We want an unsafe set tile at ship X and ship Y. Which we'll get in a second, and that's all we want to set it to is the player ship. Okay, import qualified. Yeah, that's what we want. Make that nicer looking in a sec. Okay, so that all compiles now. Okay, so we've separated our rendering from our state here, which is what we probably should have started with, but here we are. We're all good. And now we can update our state. So look at it. Let's go back over to game state. So in the game state, we have the sector tiles directly, but we want to actually derive the sector tiles using our new function. ship around. Now that we have the sector rendering. And then we can maybe tweak the rendering of the sector widget to make it kind of look like we want, and then implement more commands for sectors mode. And that kind of stuff. So, thanks for tuning in to the stream. If I've missed anybody... Oh, Alice, I missed saying hello to you. Sorry. Thanks for tuning in, Alice. It was nice to see you. And we're at the end of the stream now. So I hope you enjoyed. I do these streams, if this is your first time tuning in, I do these streams about once a week on Tuesday evenings in the Eastern Standard Time Zone, about 10 after 8 in the evenings. So if you're on the Twitch and you want to like follow, subscribe, whatever it's called on here, just click that button and you'll get your notifications if you got those all set up. Because sometimes I do surprise streams and that sort of thing. So you can also check out my schedule there and everything. Also join the Discord server. You can follow the link up there to get to it. There's a channel there for this stream where you can tell me about your projects. We can chat about any Haskell questions or any questions about the project itself. Anything you didn't want to ask on stream. And if you're tuning in from a different time zone on YouTube, you know what to do there on my YouTube channel. The code for this project, let's get that pushed up for what we have so far. Add sector tile rendering. Separate out the tiles from the sector state and generate the tiles from other state so that we can render sector. Cool. And if you want to follow along and get this code, it's up on GitHub's. I just pushed it up. I'm Agent Ultra. This is the repo for the project, Agent Ultra / Lambda Trek. You can get it there and check it out and follow along. And I'm also on the socials. I'm on the Fediverse at types.pl. I'm also Agent Ultra there. And you can follow along there too. So that's all I got for tonight. Thanks for tuning in. May your monads be free and your types always check, and we'll see you next week. Peace out.